Hey everybody, welcome back to Math 30-2. We're moving on to sinusoidal equations. Now, when we're given an equation that is y equals a sine b x minus c plus d, each one of these parameters represents one of those characteristics that we learned about in the last lesson. So for instance, the a, that represents the amplitude if we take the absolute value of it. And we also learned that there was a way to find the amplitude if we know the max and the min, and that's with this little formula here. So we take the max, subtract the min, divide by 2. We also learned that the b value represents or helps us to figure out the period, and the period is equal to, we don't need two of those, 2 pi over the b value. We also looked at this last value here, the d value, and we called that the median. And remember that the median is like the average. So we're going to add those two max and min values together and divide by 2 to find that average. We also looked at the range, and we learned that we can determine the range by figuring out the max and the min. For instance, the max can be figured out if we know the amplitude or the a value and add the d value. Likewise, we can take the negative a value and add the d value, or if you like, you can say that median value subtract the a value. And if we want to think about that in terms of a sinusoidal function, this represents our median value. And remember, if we're going down, it's still a positive a. So this minimum here would be d minus a. And then this way we're going up from the d value. So it's d plus a. So now that we know this, we're going to look at our graph and see if we can figure out what the parameters of this graph is. The first thing I notice here, we got a minimum at 0, a maximum at 100, and that would mean that our median value is going to be between those two. And from that, we can do it purely by reasoning. For instance, I know halfway between 0 and 100 is 50. So I can say the median is at 50. And that would make the amplitude 50 as well, because from 50 to 100 or from 50 to 0, it's also 50. So that means the a value is 50. What is the period? Well, the period is that length of one complete cycle. Now, in this case, we're going to go from minimum to minimum. So that's going to be 30. And our b value, well, we know that the b value now is 2 pi over the period. Remember, we just flip that equation around, which is 2 pi over 30. And we're going to reduce the 2 over 30 to say pi over 15. Now, what about that range? Well, for the range, we need a maximum and we need the min. And remember, in set notation, we go y such that 0, which is the min, is less than or equal to y, less than or equal to the max, which is 100, where the y is an element of the real number system. And what about that median? Oops, we already did that. That's for the next question. So let's move it on down. So for this question here, let's see if we can easily see things. I know this looks kind of messy. This says minus 2, and this one says plus 4. Terrible writing there. So we got this value here at minus 2, the max at positive 4, And that would mean the median, by eyeballing it and just counting, we can go up 1, 2, 3, that gets to the max. And then 1, 2, 3 brings us to the minimum. So we don't need to use the formula yet. We can kind of eyeball some of these things. So the median line is at 1. And what about the amplitude? Well, we already counted that up. It's 3 units either to the max or to the min. So we're going to say our A value is 3. Now, what about the period? Well, the period goes 1 complete cycle. And for this one, that's 20, which means our B value is 2 pi over 20. Let's reduce that down to pi over 10. So dividing top and bottom by 2. What's our range? Well, let's write that one in. Y such that. Now the lowest value there, that's -2, is less than or equal to y less than or equal to 4, where y is an element of the real numbers. And I just want to remind you that if you want to just wait for me to explain it, then pause the video and copy it down, then that might be a good idea. And that way you kind of can pay attention before you copy it down in your notes. Let's keep going. So for the next question here, let's see, we got a maximum at 1. We got a minimum at -5, okay? Now, we can again eyeball the median, but let's go ahead and use our formula this time. So median is the average, so it's the max plus the min divided by 2. Well, the maximum value is 1 plus the minimum value is -5 divided by 2 gives us -4 over 2, or -2. What is the amplitude? Well, let's use the formula again. We're going to say it's max minus min over 2, which is 1 minus that negative. So that's going to make that a positive. That's 1 plus 5, which is 6 over 2, which is 3. Now, what about the period? Let's look what we have here. So for the period, it's the distance between two maxes. It doesn't really start at 0. We could kind of eyeball it if we want, but it's nicer to do it this way. What we're going to do in this case is we're going to drop these down here. Remember, this is like an x1 value. This is an x2, so from max to max. So we're just going to say x2 minus x1, which is 7 minus 1. I realize we might be able to count it, but we're just going to show a little formula in case we have to do it where the numbers aren't so easy. So the next one here, the value of b, well, that's 2 pi over 6. And dividing top and bottom by 2, that gives us pi over 3. And the range, y such that the minimum value is -5, less than or equal to y, less than or equal to +1, where y is an element of the real numbers. Okay, let's keep going. I think you guys got it. So now what we're doing, we're given the equation, and now we're going to look at it and pick out the parameters. Now, some of this stuff is fairly straightforward. We're going to remember that the amplitude, or the A value, well, that's 2. What is the value of B? Well, the value of B is 3. That's this one right here. So y equals, let's put it down here so we all see it. Y equals sine bx plus d. That's the form that we're looking for right there. Okay, so now that means we have a period which is going to be 2 pi over the b value, or 2 pi over 3. Now this one here, 2 and 3 are prime numbers. We can't divide them, so we're done. Now what about that median value? Well, the median value is our d value, and in this case, it's going to be -8. And notice that I kept that negative. So for the d value, you got to keep the negative value there. And what does that tell us for the range? Well, for the range, we need to know the max and the min. So remember, to determine the max, and the formula is right at the top of the page, we're going to take our d value and add the a. And for the min, we're going to take the d value and subtract the a. So that means here we get -8 is our a is our a d value, and we're going to add 2, and here we got -8, and we're going to subtract 2. So that gives us -6 and a -10, and it's okay that they're both negative numbers. That's fine. And remember, we always go from min to max when we do our range. We don't want to confuse it, because think of this. The lowest number goes first, and that's going to be -10 because it's further left on the number line. So this is the way we're going to have to do it, like that. If we put the -6 down here, you're saying that -6 is less than -10, and that would be backwards. So we want to make sure we're not confusing that. So always start with the min. If you have to draw a little number line, go right ahead. Okay, what about the one up here? Y equals sine of 1/2 x plus 3. Well, what's the a value? Think about that. The a value normally is right there, but there's nothing there, so it's that hidden 1. So our a value is 1. And what's the b value? Well, it's okay. The b value is 1/2. We can have a b value that's a fraction, because we know what to do with those fractions when we determine the period. We know that it's going to be 2 pi over 1/2, but we also know that we're just going to kiss and flip those things. Remember that? That's that little way we remember. So that means it's 2 pi times 2 over 1, which equals 4 pi. And what's the median? Easy peasy. It's just that plus 3 on the end there. There we go. And now we need to find the range again, but that means we need to know the max and the min. I'll try not to get tongue-tied this time. So the max equals the d value, which is 3, plus the amplitude, or the a value, which is 1. And that equals 4. And then the min equals 3 minus the amplitude, which is 2. So what is our range? Y such that, oops, forgot the curly bracket, 2 less than or equal to x less than or equal to 4, where y is an element of the real numbers. You getting the hang of it? I think so. Let's do a couple more just to be sure. Now, what is the amplitude here? Now, the amplitude, a little bit different from we want to make sure we're taking that absolute value of -4. Remember, it was all right when the values were positive that we didn't kind of do that, but we got to make sure, because the amplitude is 4. Well, what about the b value? B value, easy peasy, 2 which means our period is 2 pi over 2, which is just 2 divided by 2 is 1. So it's 1 pi, but we're just going to write pi. The median value is that on the end there. That's the average. And that's 7. So let's go ahead and find those max and mins for the range. So again, the max equals the D value, which is 7, plus the amplitude. That gives us 11. And the minimum value is the amplitude minus, the D value, or the median minus the amplitude, which in this case is 3. So now we can say the range is y such that 3 is less than or equal to y less than or equal to 11. Y is an element of the real numbers. And one more for this type of question, just to make sure. And A equals the absolute value of 3, or the amplitude is 3. And the B value, that's 1 over 4. And we know what to do here. It's 2 pi over 1 over 4. I want to see 2 pi times 4 over 1, which is just 8 pi. And notice the smaller the B value, the bigger the period. And with the median is D. This case, it's okay. We got a -1. That's fine. Negatives are good. And let's find that max and min again. So in this case, let's take care with that -1. We're going to put that D value right there, and we're going to add the 3 to get +2. And what about the minimum value? That's -1 minus 3, which is -4. So here, notice, 4 is numerically bigger than 2, but it's a negative. So it's further to the left on the number line. So y such that -4 is going to go first. And then the max is 2. And y is an element of the real numbers. So that means that our sinusoidal function waves between -4 and 2. Can't get no lower than -4 and can't get any higher than 2. Okay, let's look at question 3. Now, before we start question 3, I want to point out there is an error in this graph. So the first thing we're going to do, we're actually going to ignore this y-axis, and we're going to take the y-axis and move it. It actually needs to be right here. I know that's kind of straight, kind of not, but we're going to put it there. So really, here is the maximum point. Let's put that in a different color. So that is at 6. And then our minimum, the minimum goes over here. This is going to be -2. So we're going to put our y-axis right there. Somehow, I'm not sure why it got moved, but there we go. So the first thing we want to do is determine the A value. Now, the A value equals the max plus the min over 2. Sorry, I got ahead of myself with explaining that the graph was wrong. Is the reason we want to find A, B, and D is because we need to figure out A, B, C, and D of this form. So just keep in mind that while we're looking for something that looks like this B value is going to have a pi fraction-y thing happening. So the B pi over C in this one actually represents the entire B of what we've normally been dealing with so far. So let's look at the amplitude first. So we're going to say max plus min 6, minus 6 minus the min, and the min is -2 over 2. And that gives us 8 over 2, which is 4. So 6 minus -2 is 6 plus 2, and we end up with 4. Now the period, let's look at the period. Now the period, we can go from max to max, min to min, but if we go from here to here, oh, this means that my scale is wrong too. So let's get rid of some of these numbers here. There, that's better. So to find the period, well, we can count. We can just count from the max to the max. So 1, 2, 3, 4, 5, 6, 7, 8. Or in other words, if we wanted to find the period, we can say this x1 or this x2 minus this x1. So 10 minus 2. Either way, we're all good. If you just want to count those up, that's okay. Just make sure you're indicating that you're counting by maybe drawing these little lines in so the person who's marking it knows you know what you're doing. So then we want to find our b value. Now the b value equals 2 pi over the value there, which is reducing it down pi over 4. So now we have our b value, we got our a value. Let's head on over to the d value. Now the d value, let's do that using the formula. Let's just get used to that. So that's the average, remember? When we have averages, we add everything up, divide by the total number, which in this case is going to be 2. So it's 6 plus -2 over 2, which gives us 4 over 2, which gives us 2. So now we have our d value. So now we have all the parts we need, and we're just going to write it as y equals 4, and then sine of pi over 4x plus our d is 2. Now notice here, this looks like A, B, C, and D. So that means our A equals 4. That B in the numerator, well, we can't see it, but we know it's a 1. C is in the denominator, and D is 2. Let's keep going. We're doing great. So let's look at 4. Now, if you looked at the Activate exercise, you kind of got an idea of how these Ferris wheels map out these sinusoidal functions. It's really just indicating the height of a particular part of the Ferris wheel, like one of those little cages you get in, and it maps out how high it goes up and down over time. So in this particular graph, the height h is in meters above the ground, and over time t in seconds, it takes a person in a chair on a Ferris wheel 72 seconds to complete 3 revolutions. And if you like, let's highlight some of that important information. So 72 seconds for 3 revolutions. When the minimum height is 3 meters, that makes sense because the chair of the Ferris wheel never touches the ground, so it's never at distance 0. And then the maximum height when you're way up in the air is 33 meters. So it's asking, at what height does a person get on the Ferris wheel? Well, before we get started, I'm all about drawing a diagram. So let's go and just draw our little diagram here. Oops, let's get, there we go. Oh, that's not what I wanted. Let's change that. I don't like an arrow. Let's just use these. There we go. So now, got our little Ferris wheel here. I think I made those lines way too long. There we go. So we got somebody in a little chair right there, living his best life. The Ferris wheel, waving. Oh, no. Oh, that kind of looks like two people. Okay, sure, it's two people, and they're waving. There we go. All right, so we have them there. They are 3 meters, so that's where the lowest part of the Ferris wheel, so it's going to be 3 meters when they get on. Then the next question is, what is the radius? Well, the radius, of course, on a circle, that's the distance from here just to the edge of the circle. So that's our radius of the circle. Now, if you looked at that activate exercise before you came to the video, that one, that radius there, that actually represents the amplitude. So if we knew the amplitude, we could figure out the radius. So let's go and do a little bit of math. That's what we're here for today, doing a little bit of math. So the amplitude equals the maximum, which is 33, minus the minimum, which is 3, over 2. So we get 30 over 2, which is 15. So what is the radius? The radius is 15, but this question has a context, meaning we have to include the units. So this is 15 meters. Now the second part D here is, where is the center of the Ferris wheel at? I guess they mean at what height is the center of the Ferris wheel? Well, that is the distance here to the ground. Where is it? So the ground is at 0. We know that when we're at the bottom, we're 3 meters above. We also know that the radius, and I'm just going to put in a different radius here. I'm going to put in this radius right here. That radius hasn't changed. It's still 15 meters. So notice what we're doing here. We're taking, to find the median value or the midline, however you want to think of that, to find that median value, we're taking the minimum value and we're going to add the amplitude value. So in other words, it's going to be 3 plus 15, which is 18, which means the median value or the center of the Ferris wheel is 18 meters above the ground. Now, how long does it take to make one revolution on the Ferris wheel? Well, we know that in 3 revolutions, it takes 72 seconds. I'm going to set it up like a little ratio here. So I want to know, how long does it take one revolution? And we're going to put, let's call it P. How long does it take one revolution? In other words, what's the period? Well, we're just going to do a little cross multiplying and dividing here. So P equals 72 seconds. And I'm going to hold on to the units because I want to show you how they all cancel out nicely. 72 times 1 rev divided by 3 revs. And that means these revs cancel, which means I'm left with 72 divided by 3, which is 24, but notice the seconds didn't cancel, so they stuck around. So how long does it take? In other words, what's the period? It's 24 seconds. And if you look at the graph, we can't tell perfectly from the graph, but that makes sense. Let's keep going. And we have another question here that's in context, meaning it's kind of a real life situation. And this one is the minimum depth of water in a harbor, and it can be approximated by the function d of t equals 5 cos 0.5 t plus 12, where 0 is less than or equal to 24. Now think about this. The depth of water in a harbor is cyclical because it as the tide goes up and the tide goes down, the height of the water in the harbor also goes up and down. So the first thing it's telling us is that, or asking us to do, is find what is the maximum and minimum value. Oh, let's go to green. Well, we know to find a max, we're going to take the d value and add the amplitude. And in this particular equation, the d value is 12, the a value is 5. So our maximum value is 17, but because this is in context, I'm going to pretend they told us that it was in meters, and we're going to do that. It's 17 meters. What about the minimum? Well, remember the minimum is the d value minus the a value because you're going down. So it's going to be 12 minus 5, which in this case gives us 7 meters. Well, then what's the range? Well, we know that. The range is just the min to the max. So we're going to say y such that the minimum is 7, less than or equal to y, less than or equal to 17, where y is an element of the real numbers. You got it. Well, what about the period? Well, let's go back to our formula. The period equals 2 pi over the b value. Now, in this particular equation, our b value is 0.5, and it's okay that it's a decimal. 0.5 is the same as a half, so if you want to even, you can put a half right there and do our kiss and flip and get 2 pi times 2 over 1, which equals 4 pi. And think about this. Period is what? What is the units? It doesn't say. I think it's hours because it goes from 0 to 24. Let's say it's hours. Now, what is the time? What is the depth of water at 2 a.m.? Okay, 2 a.m. Well, that's after 2 hours after midnight. So what we're going to do here, we're going to break out good old calculator, because we can graph sinusoidal functions on our calculator to figure out some unknown value. So let's go ahead and in here, we're going to put in 5 cosine 0.5. For our t, we're going to put x, and we're going to close the bracket. If you don't close the bracket, it's not going to graph properly, and we're going to put in plus 12. Now, in this case, we need to set our windows up, but we're going to use our range values of 7 to 17 to help us, because that means the y has to be at least 17. So we're going to make our y max go to 20. And I'm going to make the y min, I'm going to keep it at 0. If you wanted to go say 5, that's okay. I'm going to keep it at 0. They also tell us the x value or the time. It's 0 to 24. So I'm going to say 0 to 24. I'm also going to change my scale to 2. Notice I did it with the Y as well. Now I'm going to hit graph. Oh, there we go. Got our graph. Way to go. Now, this is from 0 to 24. So I want to know when X equals 2, because if we're thinking of a 24-hour clock, midnight is hour 0, right? And going all the way to the next midnight would be 24 hours. So 2 a.m. would be 2 hours. So that's when X equals 2. So how do we do that in our calculator? Well, remember, we go second trace. And we're going to hit 1 for value. Now, I know I have an old school calculator. If you got a different model, maybe even a Casio, you can head on over to our tutorial page on the website and check out how your calculator works. And we're going to find when X equals 2, what does our Y value equal? So pull that up. So we're going to go second trace. Here we're going to go 1 for value. And we're going to put X equals 2 in there. Then we hit enter and it gives us 14.7. Now, it doesn't say rounding to a particular number. Let's go to the 10th. So we're going to say 14.7 and we're going to say meters. Okay. Now, in 1 revolution, at what time is the depth at 10 meters? Okay. Well, let's figure this out. I realized I didn't draw this in. If you want, let's do that now. Okay. Better late than never. We know, I'm just going to change my line setting here a little bit. I'm going to make these a little bit smaller, like that. So we know that the minimum value that our it waves between is at 7. So we're going to kind of estimate that. I want everyone to get used to kind of drawing these things and make sure it goes all the way to 24. So that is 7 right there. Well, that means the max has to be at 17, which is just 2 above 15, kind of right there. I know this is not perfect, but we're estimating due to the graph, and we're going to just draw a line right there. We do know that the median is at 12, which is just 2 above 10, which is right there. We also know the period. And while we've been always taking this period and saying 4 pi and leaving it that, let's just go ahead and see what that equals. If we look at 4 pi, let's quit out of there and go 4 times second function pi. Oh, notice that it's 12 and a little bit, okay? So that means at 12.5, which is halfway between 10 and 15 roughly. So what I'm going to do, I'm going to take another line roughly right there and draw it like that. So the period means one cycle has to happen between 0 and this roughly 12.5. So what I'm going to do, starting up here, this is going to have to go halfway to the minimum, and then halfway it's going to go back up to the max. So we're just going to go like that. I've drawn better. I've drawn worse. There we go. Like that. And then it's going to repeat itself again. So then roughly over here. So we're going to hit another minimum, kind of about there. It's a sketch. Doesn't have to be perfect as long as some of these key features are showing up. Okay, there we go. So that's how I would do that if I did not have a graph to go by. Now, what about one revolution? In one revolution, at what time is the depth 10 meters? Okay, well, let's look at what that would look like. Well, there's a 10. Now, normally in one revolution, so between 0 and 12.5, there's actually 2 times where it's going to be there. So we got to find 2 intersections. So what we're going to do in our calculator, we're going to define 2 equations, y1, which is 10, and y2 is equal 5 cos 0.5t plus 12. Now, whenever you're doing these types of questions, I want to make sure that you are writing down your y1 and your y2 so that the person who is marking it knows that you know what equations you're dealing with. Then you're going to tell the person what you did. You're going to tell them that you went second trace and you went 5 for intersection. You're finding the intersect of these 2 graphs. This way, everybody knows that you know what you're doing. So we're going to go back to our calculator. In our y equals, we're going to add the second value of 10. We're going to hit graph. And notice we got the same graph that I'm showing right there. So we're going to find this intersection first. Second trace, 5 for intersect. Now notice this one came all the way up here. Normally, sometimes there's only one intersect and we hit enter, 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 and then we got it. The thing is, the calculator, not so smart. It can't guess. So we go to the point that we want to find. So we got to get close to it. So we're going to go enter, enter, enter. Now we find the first one, and that is 3.964. Then we're going to do the second one. I'll write these down in a second. Don't worry. So second trace, 5 for intersect, and now we're going to head over to the other one. Now we're going to go enter, enter, enter. And there's the second one. So let's write these numbers down. So the first x value that gave us this 10. And remember, it's not really an x value. So let's back that up a little bit. Let's say it's what it is. It's the time value. So the first value, t, is 3.96. The second value, t, was 8.60. And so it's asking what was the depth. So the depth is 10 meters at 3.96 and 8.60 hours. There we go. You guys are doing great. We're hanging in there for the very last question. Fanfare. Okay, last thing before we head off to do some practice work. So the alarm in a noisy factory is a siren whose volume V decibels fluctuates so that T seconds after starting, the volume is given by this fancy equation, this fancy sinusoidal equation. So at a given time T, we know the volume. So you get a siren. I won't do that anymore. But yeah, we got to figure out how loud is it at a given time. So the first thing it says, well, what is the maximum volume and the minimum? Well, we got it. We know what to do now. The max, let's stop writing in red. Let's go to green. So the max is going to be the D value, that median, so the midline plus the amplitude, which gives us 60 plus 18, which gives us 78. And remember that this is decibels. So it is decibels. They don't tell us that, but we're just going to put it, the units there. Otherwise, I would expect you to write out decibels, but the units for decibels is dB. Now, what about the minimum? We got this. We're just going to subtract the A value from the median, putting that into the calculator or doing some crazy mental math. We get 42 decibels. So what is the range of the volumes? You know this too. Y such that 42 is less than or equal to Y is less than or equal to 78, where Y is an element of the real numbers. So close, we're almost done. What is the period? Period equals 2 pi over the B value. What's that B value again? Oh, let's look. Oh, interesting. It's a fraction with pi in it. We are going to just look at this like we normally would. We're going to go 2 pi over that fraction with a pi in it. We're not going to let that defeat us. We're almost done. 2 pi times kiss and flip, 15 over pi. Oh, look what happens here. Now, if this kind of freaks you out a little bit, let's make it less freaky. We're going to put this over 1. So that's going to make that look like pi and pi cancel. And 1, well, 1 in the denominator, we don't worry about that. So that's 2 times 15, which is 30. So what is the period of this cycle? Well, they tell us that the time is in seconds, so this is in 30 seconds. There we go. Now the last one. After how many seconds to the nearest tenth does the volume first reach 70 decibels? Okay, so what really is happening here? We're saying, when does the equation equals 70? So basically, you're setting it up like this. And we're finding, what is y1? Well, y1 is 70. What is y2? Y2 is this. And in this case, still finding the intersection. This is just like the last one we did on the calculator. So we go second, trace, and 5 for intersect. So let's set this up in our calculator. If you want to pause the video, get your calculator set up too. What are we going to do here? Y equals. Oh, let's clear that out. Clear that one out. So the first one is 18 sine. Okay. Here's a little bit of a thing we want to make sure we've got going on here. It's the way, if you have an older calculator that doesn't do that dividing so nicely and make it look kind of pretty, I'm like always a bit, I'm going to go second function pi divided by 15, and I'm going to close my bracket before I put the x in there. Okay? Be safe. Then I'm going to add the 60. Okay? Bracketing on some of the older models is important. You got to know your calculator. Second one is 70. Okay? Now, in this one here, we got to go back to our range to go and look at minimum and maximums. Notice this went from 42 to 78. I'm not going to go to 0 for this one. I'm going to go to 30, and I'm going to go to 85 here, and I'm going to make this scale go up by 5s. And then because the period is 30 seconds, that means our maximum here has to be at least 30 seconds. So if you want to go 30 or higher, that's okay. So let's hit graph. Okay, it goes up, comes down, goes back up. We got one full revolution, and then we have that intersecting line. So we need to do our second trace 5. Okay, let's go. Yeah, let's do this one first. We go enter, enter, enter. Okay. Oh, wait. But look what it said. Oh my gosh. It said, what is the volume first reach 70? Look what I did there. Is that the first time it reaches 70? No. I got too excited. Let's do that again. Second trace. 5. Let's go to the first time. Okay. Click, 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 click. Okay, now we're close. Enter, enter, enter. There we go. That's the first time it hit 70. So we got to be careful sometimes when we read these things. I was a little quick to jump and then it caught my eye. First reached 70. So let's start highlighting things a little bit better. So in this case, our X, or not X, our T value here is 2.8 seconds. And remember, that's the nearest 10th. So we had to do that rounding. So the volume reaches, or first reaches, if you will, 70 decibels at 2.8 seconds. Well, that's the end of this video. If you head on over and do a little bit of practice, that would be great. I hope you have a great rest of your day. Take care.